You are enjoying this sunshiny week. If I were you, I would do my algebra homework on the porch. That's just my recommendation for making it a little bit better. Today we are going to work on section 11.2, which is simplifying radical expressions. Now, the good part is the beginning of this lesson is pretty familiar. We have covered simplifying radicals already in Algebra 1. However, we're going to take it a step further, but let's start with the basics, okay? Again, we're section 11.2, so this is page 719 if you want to follow along. I'll use some of the examples from the book and some I'll just make up. Okay, so we'll start with just simplifying radicals. Let's say I have the radical, the square root of 32. Okay, most of you remember that when we simplify that, we consider what perfect squares go into 32. It's also in your best interest to get to the largest perfect square. You can do it when you start with a smaller one, but it's easier when you think of the biggest perfect square. Now, again, if you're struggling with your math facts, if those aren't quick for you, this is going to be a challenge, okay? So those fundamentals are important. You can look at the square root of 32 like 16 times 2, right? You can simplify it, separate it like that, two factors. Square root of 16, hopefully, you know easily is 4, and you're left with the square root of 2, okay? So that's the simplest way to handle that radical, the square root of 32. What about if we have letters? We have covered this also, okay? Again, you're looking for perfect squares, okay? When you do this, handle the number first. Most of you recognize square root of 9 is 3, okay? But I'm still left with x cubed, all right? What you want to do if it's a square root of that, which we can just pretend there's a 2 there, that's a square root. Think about how many times does 2 go into 3? One time, right? If I thought about that, some of you like to think about it like, oh, that's x times x times x. We've talked about it. Okay, I could think about it being x squared times x because I know that I add those exponents, okay? Either way, let's look at it like this if you did it. I can take out the square root of x squared is x. So I can take an x out, and I'm left with 1x underneath the radical sign. How do I know if I did that right? Well, you can take this term right here and square it. What's 3 squared? 9. What's x squared? X squared times x. It's right here. X cubed. Okay, so you know you've done that properly. That should be pretty familiar. We've kind of covered things with radicals before. Let me find my eraser here. All right, so that's pretty familiar. We're going to work on, well, what if we have fractions? And what if I have a radical sign in my denominator? Okay? So, let's look at example 2. Okay? When you multiply radicals, you just multiply whatever numbers are underneath the radical sign. They give you example A there. Square root of 6 times the square root of 6. Okay? What they're trying to get you to recognize, and we've discussed this, is when you multiply a square root times a square root, you end up losing the square root. Well, let's see how that works, okay? I can look at it like the square root of 6 times the square root of 6. I multiply what's underneath. That's the square root of 36. What's the square root of 36? All right, we recognize, oh, well, that's back to just 6. The point we want you to see here is a radical times a radical, you end up with just the term underneath. Let's look at that again. What if I have the square root of 4 times the square root of 4? Okay, I can multiply that out. Sure, that's the square root of 16. I recognize that's 4. Simply, oh, a square root times a square root. Oh, I'm just left with whatever was underneath my radical sign. Okay? Look at example B. Here you have letters involved in that. The square root of 3x times 4 square root of x. Okay? So when you multiply variables, remember you're adding the exponents. And I'm not going to go through, you can see that one. I think I will choose to work through another one with you. Since you can see those, I mean, those are worked out pretty well for you. You can see all the steps. Let's look at something like 3 square roots of b times square root of 2b cubed. Okay? So, what do we do when we multiply these? Okay? I'm multiplying, and all I can do is multiply what's underneath the radical sign. So the 3 stays here. I'm still left with the 2 here, because there's nothing there. B times b cubed is b to the 4th, right? We add those exponents. Okay, well, when I have b to the 4th, I have to recognize, again, you see the 4, hopefully you recognize, oh, that's b squared times b squared. So your final answer there would be 3b squared square root of 2. Okay? So, throw in some variables, the same principles still apply. Alright? Now, on to example 3, when you are dividing. Okay, and they show you, you have the square root of 13 over 100. Okay? Probably the easiest way to think about that is separating it. Oh, I'm looking at it like the square root of 13 over the square root of 100. Okay? No simplifying this. There are no perfect squares in 13. That stays. What is the square root of 100? 10. Okay? So that's how you simplify when you have those division type problems. If I had square root of 11 over d to the 4th. Okay, you might want to separate that. Look at them as 2 different problems. You cannot simplify the square root of 11, but the square root of d to the 4th is d squared. All right, so that's what happens when you have quotients under a radical sign. Now, there's another step where if you have a radical sign in the denominator, this is we're getting onto example 4 on page 721. Okay, so if you look at it, 5 square roots of 7. Okay, you cannot leave a radical sign in the denominator. Well, how do I get rid of it? Remember, if I had something like when we're looking at denominators, as long as you multiply the top and the bottom by the same factor, it keeps the value the same. Okay? In this case, we're going to multiply these both by the square root of 7. Okay? Square root of 7 over square root of 7 is 1, so I'm not changing the value of it. What I am doing is allowing this to be canceled. Okay? When I multiply here, you get 5 square roots of 7. Square root of 7 times the square root of 7. Remember, this is back to that original idea we worked with in the beginning. Theoretically, square root of 49. Yes, but what is that? That's 7. So with square root times the square root, you just end up leaving that term down there without a radical sign. So your final simplified answer is 5 square roots of 7 over 7. If you look at little b on example 4 there, okay, square root of 2 over square root of 3b. Again, we don't want the radical sign in the denominator. How do we fix that? We multiply it by whatever's in the denominator, top and bottom. Okay? So, I end up here with the square root of 6b. Can't simplify that. What do I end up with in the denominator? Square root of 3b times that. This radical sign disappears and you're left with 3b. Okay? Doesn't simplify, but you don't have a radical sign in the denominator, which is the important part there. The last section today is adding and subtracting with a radical sign. Okay, so I'm on page 721. I'm looking at example 5, adding and subtracting. The important thing to realize here is that if the radical, whatever underneath the radical is the same, you can combine. And you're looking at the terms in front. But if it's not, you can't. So, what does that look like? Let's work through this one. Okay. All right. I'm focusing on what is under the radical sign. And we would consider it like, oh, square root of 10, square root of 10, as in they're sort of like terms, okay? So then I look at what's in front. 4 and a minus 9, okay? 4 minus 9 is negative 5, square roots of 10. You don't change what's under the radical sign. You're only dealing with the term in front. I can't do anything here. Nothing else combined with that. So that's as simple as that gets to combine radicals. Okay, let's look at another one. What about if I had to, this is number 6 on the guided practice. If I have 2 square roots of 7 plus 3 square roots of 63. Well, nothing combines there, right? But the problem is you have to recognize 63 is not simplified. That can be simplified, okay? 63 is 9 times 7. Square root of 9 is 3. So I would have to multiply that 3 times this 3. So all of that simplified would be 9 square roots of 7. Do you see what we did? Okay, it would be like square root of 9 times the square root of 7. Square root of 9 is 3, but I have a 3 here. So I have to multiply that and get 9 square roots of 7. Now I can combine this. 2 square roots of 7 plus 9 square roots of 7. 2 plus 9 is 11 square roots of 7. If you think about it, like combining like terms as far as what's underneath your radical, that will help you. Okay? Same concept on page 722. We're talking about multiplying there. You can multiply through with a radical sign. Look at little a on top of page 722, square root of 5. You can see they distribute there. And so you get 4 square roots of 5 minus 5 square roots of 20. And they show you there, when you multiply square roots, you multiply what's underneath. So the 5 times 20 becomes the square root of 100. 4 square roots of 5 minus the square root of 100. And they show you that's 4 square roots of 5 minus 10. Okay? They walk that through pretty well step by step for you. So they give you another example in little b. I didn't give you too many problems like that. Just giving you a little practice. If one of these concepts seems tougher than another, pick more. I just gave you a couple from each section. I gave you an even and an odd so you can make sure you're on track. Again, if you have questions, Google me on Wednesday from 2 to 3 is my time for you. Work some more odd problems if you're struggling. It's difficult because we can't just go through problems and practice a lot in class. I know you're not going to watch a video. If I make a 40-minute video of me just doing a bunch of problems, you're going to tune me out. So be good learners, be diligent, figure out what do you need. If one of these concepts is real simple to you, awesome. If one's a struggle, pick out some more odd problems and work through those. All right? Hope it goes well for you. I know you're learning a lot. I know it's challenging, but I'm proud of all that you're getting done. Let me know if you have questions.